Hello, welcome. In our previous tutorial, we looked at confidence interval for mean when the population standard deviation is known and also when the population standard deviation is unknown. But in today's tutorial, I'm going to take you through confidence interval for population proportion. So without wasting much time, let's start. Now when we talk about proportion is just a fraction, ratio, or percent indicating the part of the sample or the population having a particular trait of interest. So this tells you that we can have a sample proportion and we can also have a population proportion. In this topic, the formula we are going to be using is p hat minus z multiplying square root of p hat times q hat divided by n less than p hat plus z multiplying square root of p hat times q hat divided by n. You can also compress the formula and write it p hat plus or minus z multiplying square root of p hat times q hat divided by n. This is because at the lower limit, the p hat here is the same as the one at the upper limit. And then the z multiplying square root of p hat times q hat divided by n is the same as what is here. The only difference is that the upper limit is a plus and then the lower limit is a minus. In our previous lesson, I told you that the part that you have z multiplying standard deviation over root n is called margin of error. And then in the t distribution, the part that you have t multiplying standard deviation over root n is also called margin of error. So same thing applies here. Here, the part that you have z multiplying square root of p hat times q hat divided by n is called margin of error. So you can choose to write the formula like this or in a compressed form like this. Okay. Now to use this formula, you always have to check if n times p hat is greater than or equal to 5 and then n times q hat is also greater than or equal to 5, where p hat is equal to x divided by n, just like how you find probability of success, and then q hat is equal to 1 minus p hat. So whenever you have the p hat, you can easily get a q hat by saying 1 minus p hat. Now remember, under confidence interval for large sample, that is where we look at the z distribution. I gave you some common confidence level and their various z-scores, and I also show you how to find them yourself. And the common confidence levels I gave you together with their z-scores are, I told you that whenever you have a confidence level of 90%, the z-score is 1.645, and then 95%, the z-score is 1.96, 98% is 2.33, 99% is 2.575. So you have to keep these various z-scores for this confidence level. You can also be given 80%. There you would have to find a z-score yourself. But these are the common ones. You can keep them without necessarily finding them again when you are in the exam. Now if you've not watched the video on the confidence interval for large sample that I'm talking about, you can check the link to that video in the description area below. So let's take some questions on this topic and then see how to solve them. So the first question says, a survey of 1,550 KNUST students by Etonam found that 875 of them prefer to buy gobe at Queen's Hall Market. Find the 95% confidence interval for the true proportion of KNUST students who prefer to buy gobe at Queen's Hall Market. Now to solve this, the first thing we need to know is our sample proportion. Now when you look at the question, you took a sample of 1,550 students and then you ask them if they prefer Queen's Hall gobe or not. And it happens that 875 of the sample of 1,550 prefer the Queen's Hall gobe. So to get your p hat, you just say x divided by n. So your x is the number of students who prefer the gobe, and then the n is the sample size. So to get your p hat is equal to 875 divided by 1,550, and that will give you 0.56. So now you've gotten your p hat. Now after getting your p hat, you can find q hat also. To get q hat, you just say 1 minus p hat. So 1 minus 0.56 will give you 0.44. Now the question says 95% confidence interval. Remember, In Z distribution, anytime you have 95%, your Z-score will be 1.96. So to solve this, let's recall the formula. The formula says P hat minus Z multiplying square root of P hat times Q hat divided by N less than P hat plus Z multiplying square root of P hat times Q hat divided by N. Remember, I told you can compress the formula. Now, after writing the formula, you substitute the various values into the formula. Our Q hat is 0.44, our Z is 1.96, and then our small letter N is 1550. So let's substitute those values into the formula. So we're going to have 0.56 minus 1.96 times square root of 0.56 times 0.44 divided by 1550 less than P less than, then you repeat the same thing at the upper limit, but use a plus in this one. Let's find the margin of error first. That is 1.96 times square root of P hat times Q hat divided by N. So when you put this part on your calculator, you're going to get 0.0126. So we're going to have 0.56 minus 0.0126 less than P less than 0.56 plus 0.0126. So we take 0.56 minus 0.0126, and that will give us 0.5474 less than P less than, when we add 0.56 plus 0.0126, we'll get 0.5726. So this is the final answer. Now, after getting your answers, you can convert them to percentages. That is 54.74%, and then the upper one will be 57.26%. So you can conclude that one can be 95% confident that the true proportion of KNUST students who prefer to buy Gobe at Queen's Hall Market is between 54.74% and 57.26%. So that is the answer to this. Example 2 says, a survey of 1,721 found that 15.9% of individuals purchase religious books at a Christian bookstore. Find the 95% confidence interval of the true proportion of people who purchase their religious books at a Christian bookstore. To solve this, first look at the question. The sample size has been given as 1,721. But when you read further, the question says, found that 15.9% off. It means that this is already giving you the P hat. So straightforward, the P hat is 15.9%. And when we say 15.9%, it means 15.9 divided by 100. So that is 0.159. In example 1, we found P hat ourselves by taking x over n. But in this one, the P hat has been given as 15.9%. It's in percentage. So just convert it to decimal. Okay, so that is the P hat. So we find the Q hat ourselves. So the Q hat will be 1 minus 0.159, and that will be 0.841. Now when you look at the question, it says 95% confidence interval. Because in confidence interval for population proportion, we are using Z. So for 95% confidence, the Z should be 1.96. Now we know the P hat, we know the Q hat, and then we know the Z. So we can recall the formula. The formula says P hat minus the margin of error less than P hat plus the margin of error. So we substitute into the formula. So let's substitute. So we're going to have 0.159 minus 1.96 times square root of P hat was 0.159 times Q hat was 0.841 divided by 1721. That's the N. Less than P less than, then we repeat the same thing at the upper limit. Okay, but at the upper limit you use a plus. So when you enter the margin of error on your calculator, that is this part, you are going to have 0.017. So you write 0.159 minus 0.017 less than P less than 0.159 plus 0.017. So take 0.159 minus 0.017. That will give you 0.142. Less than P, less than. When you take 0.159 plus 0.017, you get 0.176. So that's the answer to this. Now you can convert it to percentages, and that will be 14.2% less than P, less than 17.6%. So you can conclude that one can be 95% confident that the true proportion of people who purchase their religious books at a Christian bookstore is between 14.2% and 17.6%. So before we move to another subtopic in this video, let's take a third example. Example 3 says, a survey of 920 students in Brunei found that 46.8% prefer to order a ride when going for a lecture. Find the 90% confidence of the true proportion of all the students in Brunei who prefer a ride when going for a lecture. So to solve this, first we need to know our p-hat, isn't it? Now, here the p-hat has been given in percentage, okay? So you just convert it to decimal. So our p-hat is 46.8%, and that is 46.8 divided by 100. And that will give us 0.468. And then we find a q-hat too. To get a q-hat, it is 1 minus p-hat. Okay, so 1 minus 0.468 will give you 0.532. Now, because we are dealing with z in this topic, whenever you have 90% confidence, the z-score should be 1.645 or 1.65. Okay, but I will be using 1.645. So, since we know our p-hat, we know the q-hat, and then we know the z-score, we also know the sample size. That's small letter n. That's 920. Okay, so we can recall the formula, which says p-hat minus margin of error less than p-hat plus margin of error. Remember, p stands for population proportion, and then p-hat stands for sample proportion. So let's substitute into the formula. So we're going to have p-hat, which is 0.468, minus z, which is 1.645, multiplying square root of p-hat times q-hat. That's 0.468 times 0.532 divided by n, which is 920, less than population proportion, less than. You repeat what you've written at the lower limit at the upper limit also, but at the upper you use a plus, and then at the lower you use a minus. That's the only difference. So when you compute the margin of error, that is this part, you get 0.027. So you have 0.468 minus 0.027 less than p, less than 0.468 plus 0.027. So 0.468 minus 0.027 should give you 0.441, less than population proportion, less than. When you add 0.468 plus 0.027, you get 0.495. So that's the final answer to this. But you can convert it to percentage. So in percentage, there will be what? 44.1%, and then the upper will be 49.5%. So you have to conclude that one can be 90% confident that the true proportion of all students in Brunei who prefer a ride is between 44.1% and 49.5%. So let's move to the next subtopic. So we want to look at how to find the minimum sample size to estimate a population proportion. Now, when given a C level of confidence and a margin of error, the minimum sample size, that's a small letter n, needed to estimate the population is n equals p-hat times q-hat multiplying z over e all square. You can also write it p-hat times q-hat times z square over e square. This formula was derived from, now remember, in the formula for confidence interval, the part that comes after the sign, that is z multiplying square root of p-hat times q-hat divided by n, is called margin of error, isn't it? We use it to represent margin of error. So margin of error, that is E, is equal to Z multiplying square root of P hat times Q hat divided by N. Now let's make N the subject from here. So in an attempt to make N the subject, what is the LCM here? The LCM is square root of N. Okay, so we can multiply both sides by square root of N. So when we multiply both sides by square root of N, we're going to have square root of N times E is equal to Z multiplying. Remember that when you have square root of A over B, you can separate it and make it square root of A divided by square root of B. So you can rewrite this as this. That is square root of P hat times Q hat divided by square root of N times square root of N. So this square root of N will cancel this. So you're going to have square root of N times E. That will be E times square root of N is equal to Z multiplying square root of P hat times Q hat. Now since our interest is to make N the subject, we can divide both sides by E. So when we divide both sides by E, we have E root N divided by E equals Z multiplying square root of P hat Q hat over E. So this E can take away this. Okay, so we're going to have square root of N equals Z multiplying square root of P hat Q hat divided by E. So our interest is to make N the subject, not square root of N. So if that is the case, then we square both sides so that the square can take away the square root affecting N. So when we square both sides, the square will take away the square root here, isn't it? So we're going to have N equals Z multiplying square root of P hat Q hat divided by E all squared. Remember that when you have A times B all exponent 2, it can become A squared times B squared. So if that is the case, you can rewrite this part as N is equal to Z squared times square root of P hat Q hat square divided by E square. The square will affect everything in the bracket. Okay, so this square can also cancel this root. So you are going to have P hat Q hat alone times Z square over E square. So that's the same thing we've written in this form. So this is where we derive this formula from. So let's take a question on this and also see how to solve it. A researcher wishes to estimate with 95% confidence the proportion of people who own a home computer. A previous study shows that 40% of those interviewed had a computer at home. The researcher wishes to be accurate within 2% of the true proportion. Find the minimum sample size necessary. So to know how questions on this look like, the question will usually tell you to find the minimum sample size necessary. Okay, so to solve this, let's recall the formula for sample size N. So sample size is equal to P hat times Q hat times Z square over E square. Now when we look at the question has given us P hat. The question says a previous study shows that 40% of those interviewed had a computer at home. So meaning the P hat is 40%. That is 0.4 when you convert it to decimals. And the Q hat should be 1 minus 0.4, and that will be 0.6, isn't it? Also, the question gave us 95% confidence. And remember, under Z, whenever you have 95% confidence, the Z score is 1.96, isn't it? So we know our Z score also. Now to know the margin of error, whenever you have a question on this, you usually see words like accurate within 2%, accurate within 4%, accurate within 6%, those kind of words. Okay, so you should know the 2% is the margin of error, and that is 0.02 in decimal. So we are going to substitute that into the formula. So that will give us 0.4, our P hat is 0.6, so times 0.6 times, since our Z score is 1.96, then we square it, divided by 0.02 squared. The margin of error is 2%, and in decimal it will be 0.02. So when you check 0.4 times 0.6, you get 0.24. Okay, and then when you check 1.96 squared divided by 0.02 squared, you should get 9604. So you're going to have 0.24 times 9604. So when you multiply, you get 2304.96. Whenever you are finding minimum sample size and then you get a decimal, please always run it up to the nearest whole number. So when we run this up to the nearest whole number, it should be 2305. So the minimum sample size necessary to be accurate within 2% of the true proportion is 2305. So let's take another example and see. A researcher wishes to estimate the proportion of executives who own Carrefour. She wants to be 90% confident and be accurate within 5% of the true proportion. Find the minimum sample size necessary. So to solve this, first, since the question says find the minimum sample size necessary, then we are going to record the formula for the sample size, which is n is equal to p hat times q hat times z square over e square. We are using the proportion sample size formula because the question says true proportion. When you look at this question, it says she wants to be 90% confident. So in Z, whenever your confidence level is 90%, your Z score should be 1.645, isn't it? And then when you look at this, they say accurate within 5%, meaning the margin of error is 5%, and that is 0.05. But when you look at this question, you can see that we don't know the P hat, and then we don't know the Q hat also. So whenever you have this kind of question, just take the P hat as 0.5 and the Q hat as 0.5. So let's substitute into the formula. So that will be 0.5 times 0.5 times 1.645 squared divided by 0.05 squared. So 0.5 times 0.5 should give you 0.25. And then 1.645 squared divided by 0.05 squared should give you 1082.41. So we write that down. So 0.25 times 1082.41. So when you multiply 0.25 times 1082.41, you get 270.6025. Now, I told you that whenever you get a decimal for minimum sample size, always run it up to the nearest whole number. Upward, not downward. Okay, so that will be 271. So the minimum sample size necessary to be accurate within 5% of the true proportion is 271. So we are going to end this here for now. So our next topic is confidence interval for population variance and standard deviation. You can check the link for it in the description area below.